Hi, this video shows how to factor quadrinomials. Now, what are quadrinomials? Quadrinomials are polynomials which have four terms. So this is an example of a quadrinomial. You have 1, 2, 3, 4 terms. Here's another example, 1, 2, 3, 4 terms. And here's another example. So all these examples that you saw are quadrinomials. Now, before I show how to factor quadrinomials, um, let us first discuss uh, factoring common binomial factors. You're already familiar with factoring common monomial factors. That was done in a previous lesson. Now, this might be less common, factoring common binomial factors. So, what you see on the screen is actually a binomial. This is just a binomial, although you see so many terms there. This is just a binomial because the plus sign here indicates that the first group is a monomial and the second group is another monomial because they're multiplied together due to the presence of the parentheses. So this is actually a binomial. Now, within its group, there is a common binomial factor. So as you can see, in the first group, you have x minus 9 as the first factor. In the second group, you also have x minus 9 as the first factor. So that means we can factor this out. We can factor out x minus 9. Let's do that. So we're going to factor x minus 9. All right. Now let's observe what happens. So x minus 9 was factored from both terms of the binomial, and the rest were put together. So x plus 4 is here, x plus 4, and then plus 5x minus 3, which is here. All right. So after you factor x minus 9, you're going to get a quadrinomial. This is now a quadrinomial because there are four terms. Right. However, we can simplify this by combining like terms. So let's put together the like terms there. So we added x plus 5x and we got 6x. And we can combine the constants and we'll get 6x plus 1. All right, so these are the factors of the expression that you see here on top. All right, so that's how you factor common binomial factors. Let's discuss another example. All right, this is also a binomial, but the terms consist of binomials likewise, just like the previous problem. Now, in the first group, x plus 2 is the second factor. In the second group, x plus 2 is the first factor. Now, it doesn't matter. The order doesn't matter. As long as you have common binomial factors, you can factor it out of the expression. Let's do that. All right, let's show the steps. So you see, from the original, x plus 2 was factored out. And the rest of the terms were put together. X minus 3 is here, x minus 3. Now, the negative sign here must be distributed to both of these terms. So, you'll notice 4x becomes negative 4x, and 4 becomes negative 4. Now, we can combine like terms just as in the previous example. So, x minus 4x becomes negative 3x. We can also combine the constants. Let's do it here. All right. So now everything has been combined. We don't have any more like terms here in the final form. So these are the factors of the original problem on top. Right. So you have x plus 2 and negative 3x minus 7. Now, we're going to use this concept when we discuss factoring quadrinomials. Right. So, let's go to the quadrinomials. So, the first thing that you have to do when you have quadrinomials like this is you group them together. All right. So, we're going to group the first two together. All right. So, we group this together and we group the last two together. We have already done this process before when we discussed factoring type 2 general trinomials. The process is similar. All right, now from each pair, we are going to factor out the GCF. So for the first pair, you factor out x, and then what's left is x plus 8. And for the second binomial, we can factor out the common monomial factor, which is 2, which leaves us with x plus 8. All right, at this point, you'll notice that the resulting binomials, this and this, are the same. So just like what we did earlier, we can factor this out, all right? And we combine this. We can combine this and this. So we put those two together. So you have x plus 2. And the partner is the common binomial factor, which is x plus 8. So these are the final factors of the quadrinomial which we had earlier. Let's move on to the second example. So first, we group the first two terms. And then we group the last two terms. Now notice that we're introducing a parenthesis after a negative sign. I've already mentioned this in the previous lesson that when you introduce a parenthesis after a negative sign, you have to change the sign of the terms inside. So this becomes positive and this becomes positive likewise. Now we factor the GCF from each pair. So here we factor out x and we get x plus 10 inside. For the second pair, we factor out 5 and we get x plus 10. So now you'll see that we have a common binomial factor, x plus 10. So we can put their partners together. So that becomes x minus 5. And the partner is the common binomial, which is x plus 10. All right, so these are the factors of the original quadrinomial. Now let's discuss the last example. This is similar, except that there are coefficients. There are more numerical coefficients to deal with, but it's essentially the same process that we're going to go through. Group them together. Now there's a negative sign here, so make sure you change the sign of the second term of the second binomial. Now let's factor the GCF for each pair. So for the first, we can factor out 4a, which leaves us with a plus 20 divided by 4 is 5. All right, for the second pair, we can factor out 3. And that leaves us with a plus 5. All right, so we have a common binomial factor. We put these two together for a minus 3, and the partner is the common binomial, which is a plus 5. So there, these are the factors of the original quadrinomial.